This is the part 2 to the final review for Math 136, starting with number 10. Solve the absolute value equation. The first thing you want to do when solving an absolute value equation is to isolate the absolute value. So we're going to add 2 to the other side and then divide by this 3 that's out front. You do not want to distribute that because if it had been negative, that doesn't distribute correctly. Now, when you're dealing with an absolute value equation, there are two possibilities for the inside of this absolute value. Either this was a -4 before they put the absolute value on it, or a +4. So we set the inside of x plus 1 equal to both of those possibilities. So either my inside is -4 or my inside is +4. When we solve, we get the answers of -5 and +3. So two solutions for an absolute value equation. For number 11, you're trying to solve a radical equation. So same kind of idea, you want to isolate the radical. So we will move over that 4 by subtracting it. To get rid of a square, we remember, or a square root, we square. So we're going to square both sides. This will need to be FOILed because it is a binomial. So this would be 2x minus 5 equals x minus 4 times x minus 4. We will FOIL that out. So that would be x squared minus 4x minus 4x plus 16. Combine like terms. Move all of the values to the same side since there's an x squared. So we're going to have 0 over here on the left. And x squared minus 10x plus 21. Factor, if it factors, which ours does, into -7 and -3. And you solve and get two possible situations. But the problem is you must always check with a radical equation. So if we plug those back into the original, 2 times 7 minus 5 under a radical, and then plus 4 equals 7. That would be 14 minus 5 plus 4 equals 7. That is the square root of 9 plus 4 equals 7. Square root of 9 is 3, and 3 plus 4 does equal 7. So 7 is good. Now we're going to check 3. 2 times 3 minus 5 plus 4 equals 3. That would be 6 minus 5, so that's the square root of 1, plus 4 equals 3. That is 1 plus 4, which does not equal 3. So 3 is extraneous. Looking at number 12 next. This is an absolute value inequality. They break down into two general cases, whether or not you're dealing with a greater than or a less than. So we need to isolate the absolute value again. So I'm going to subtract 1 over first from right here. So that would be greater than 6. Then divide by 2, which gives me greater than 3. As long as this is positive, then you're going to be able to try to solve it. If this was negative, you would just have to determine if the statement is never true or always true. So for us, since this is positive, we have two cases. When you're dealing with a greater than and an absolute value and a number on the other side, you go towards negative infinity and towards positive infinity with your solution. If you have an absolute value and you have a less than and a positive number, you stay between two values. So you go in the middle. So for us, we're going to do two different cases. It's 3x minus 1 is less than -3. That heads us towards negative infinity, so to the left and negative. Or, since it's greater, 3x minus 1 is greater than 3. So notice that case, you just drop the absolute value. We would add over 1, so that would be -2, divide by 3, so it looks like less than -2/3. On this side, I'll add 1 and then divide by 3, or greater than 4/3. So our interval notation, because we do have to write it in that, would be negative infinity to -2/3. That's this part right here. So that's to the left, unioned with 4/3 to positive infinity, which is the greater than case. All right, number 13 is a rational inequality, which means this is the first time we introduce the idea of the chart method. So the big idea is that you need this to be 0. So we need to subtract that 2 over. I'm going to write it as 2 over 1. Because the next thing is I'm going to try to get a common denominator by multiplying top and bottom of that second fraction by 3x minus 5. So I get x, and then I need to distribute not just the 2, but the negative with it. So this would be negative 6x and then positive 10, all over now a common denominator of 3x minus 5, greater than or equal to 0. Combine like terms on top. And this is now our simplified rational inequality, so that we have 0 on this side. You get 2 critical values out of this. The top critical value, you set negative 5x plus 10 equal to 0 to figure out that value. So we would subtract over 10 and then divide by negative 5, so we get 2. For the bottom value, we would set 3x minus 5 equal to 0. So that looks like it's going to be 5/3. The big problem with rational inequalities is that just because you see a equal to bar doesn't mean everything's closed. In fact, the bottom is always open no matter what. The top obeys the inequality. So in this scenario, since there is an equal to, the top will be closed. Your next step is to come up with a sign chart. This is the first place we learned this, and you place these in order from least to greatest. So 5/3 is smaller and it is open, and 2 is bigger and it is closed. That helps me set up my interval notation with when are they parentheses and when are they brackets. I pick a test value in each region, so smaller than 5/3, I'm going to go with 0. 5/3 is about 1.6 repeating, and this is 2, so we're going to have to use a decimal. I'm going to use 1.8. And then something bigger than 2, I'm going to use 3. You take your factors from your fraction, you set them over here in this column, and you're hoping for greater than or equal to 0, which means our final answers we want to be positive. We just plug our test values in one at a time and ask, is this come out positive or negative? So 0 plugged in here would be a positive. 0 plugged into the second one, though, would be a negative. A positive over a negative is a negative. We'll need our calculator for the next one because it's a decimal. So negative 5 times 1.8. And then we're supposed to add 10 to that. So that comes out as a positive. Then we have to do 3 times 1.8, but then minus 5. That also comes out as a positive. So 2 positives make a positive. That is what I want, so that's definitely an answer region. And then 3 times negative 5 would be negative 15, plus 10 would be negative. 3 times 3 is 9, minus 5 would be positive. A negative and a positive make a negative. So there's only one answer, and that would be 5/3 to 2 with a bracket on the 2. Okay, 14 has multiple parts, so let's look at it. We have 2 points, 4, -3, and 6, 2, and we want to do the following things. Find the distance. So we need to know our distance formula, which is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And then we label these, so x1, y1, x2, y2. And we plug them in. So this would be the square root of 6 minus 4 squared plus 2 minus -3 squared. That would be a 2 squared, and this is plus plus, so that would be plus 5 squared. Make sure you follow the order of operations, so parentheses first, then exponents. So that would be 4 plus 25. And if we add those together, that's square root of 29, which is reduced. There's no perfect squares that go into 29. To find the midpoint, we use a different formula. You add the x's together, you cut them in half. You add the y's together, you cut them in half. So this would be 4 plus 6 divided by 2, comma, negative 3 plus 2 divided by 2. So that's 10 over 2, which would just be 5, and this would be negative 1 over 2. So that's my midpoint. Part C says find the equation of the line through A and B. So we're just trying to find the equation of A to B. So that means we need our slope. Again, we've got our y2, x2, y1, x1. So this would be 2 minus negative 3, that's our y's, over 6 minus 4. So that's 2 plus a positive 3 because it's plus plus there, so that'd be 5 over 2. So since we know our point-slope formula, we can then find the equation and solve it for slope-intercept. And you can use either one of the points. I'm going to use the point 6, 2. So this would be y minus 2 equals 5 halves x minus 6. If you want, you can distribute the 5 halves, or you can multiply, remember, the 2 to the other side. So this 2 times 2. That will cancel out that denominator. And so we get 2y minus 4 equals, we still have a 5, so 5x minus 30. And we're supposed to be solving for slope-intercept, so we're going to move everything away from y. So we'll add 4. So this would be 2y equals 5x minus 26, and divide everything by 2. And 26 divided by 2 goes evenly, so that's negative 13. Be careful with D because of the word perpendicular bisector. So first of all, we're wanting the perpendicular bisector of AB. Well, the slope of AB we just used was 5 halves. So a perpendicular slope to that would be flip it and change the sign, so negative 2/5. But because of the word bisector, we have to use our midpoint when we do our formula. So y minus negative 1/2, because that was our midpoint's y, equals negative 2/5. And then we have x minus, I'll have to look back up here, I think it was 5, yes. So x minus 5. In this scenario, because there's a fraction on the other side, I actually am going to distribute the negative 2/5 first. All I did was clean up the minus and negative. So if I distribute that, that would be negative 2/5 x, and then when you multiply negative 2 over 5 times negative 5, you get positive 10 over 5, which is positive 2. So the 5's cancel out, and negative times negative makes a positive. I would then multiply everything in this equation by 10 to get rid of all of our fractions. So just a slightly different approach to get rid of those fractions. That would be 10y plus 10 divided by 2 would be 5. That leaves us with a 2 times a negative 2, so that would be a negative 4x on the other side and a positive 20. We're supposed to get this one in general form, so ax plus by equals c. So we're going to add the 4x over, and then we will end up subtracting the 5 over. So 4x plus 10y equals 15. So there are all the parts to number 14. For number 15, we're looking at the difference quotient, which is just 2 function evaluations and then simplified down. So you're focusing on these 2 things, f of x plus h and negative f of x. So when we do f of x plus h, you take your function, you write it as a shell, so x goes away, and inside that you write the x plus h. This will need to be FOILed out because it's being squared. So this would be x squared plus xh plus xh plus h squared, just foiling. Distribute the 4. The 5 doesn't get the 4 since it's out of the parentheses. And then combine the like terms. So just those 4 terms right there are my yellow piece up top. We need to also find the blue piece, the negative f of x. I'm going to give myself a little bit more space on this one. So to find negative f of x, you just take your function and multiply it by a -1, essentially. So -1 times 4x squared minus 5. So that would be negative 4x squared plus 5. Okay, so we take this answer right here and this answer right here, and that becomes our yellow and blue on top. So I'm going to take these two together, and I have 4x squared plus 8xh plus 4h squared minus 5 minus 4x squared plus 5, and don't forget all of that is over h. If we've done it correctly, some things should cancel out. And then we're left with 8xh plus 4h squared over h. Since everything has an h, we can divide it out one at a time. So my final answer is 8x plus 4h. Okay, let's look at number 16. Find the domain of the following function. So domain means what can you plug into the function. So we know if there's fractions, anytime you have an x in the bottom, you can't equal 0. So if we factor that, that would be a -8 and a -5. That multiplies to 40 but adds to -13. So right away I know that you can't equal 8 and you can't equal 5. Because of the radical, radicals have to stay greater than or equal to 0. So we have to set that greater than or equal to 0. So that would be greater than or equal to 6. If you think about that on a number line, so here's the number 6. We are shading to the right. The other two numbers need to be skipped over. Well, 5 is over here. We've already skipped over 5. But 8 is going to be on this side, so we need to create an opening on that specific number. So now, instead of shading all the way, we have a gap. Now, if the number 5 had been like a 10, we would have had 2 gaps, because there would have been 2 numbers that we had to remove from the shaded part. So when we write this in interval notation, you just read it. So this would be bracket 6 to 8, union with 8 to infinity. And they did want interval notation. All right, we just have 2 more for the end of part 2. So for number 17, this is a transformation. We have our parent graph here. It's a square root. If you remember, the square root function looked like a parabola on its side, but only half of it's there. It had the point 0, 0, 1, 1, and 4, 2. If you don't feel comfortable with that, remember you can do a table of values to find out what these values of square root of x are. This is a -4 inside. That means we are having a horizontal shift. And that means we're going to move to the right 4. So you always do opposite of what you see if it's under the parent. This -2 at the end is a vertical shift. And that means we're going to move exactly as we see. So that's going to be down 2. And then we also want the domain. Since there's a radical involved, we have to set that part under the radical greater than or equal to 0, just like the previous problem. So my domain is x is greater than or equal to 4. So even if you're not good at the parent graph, let me show you an alternative way to get the same information, and then I'm going to show you that it matches the shifting. If you have your domain, you can just do a table. You want to pick 4 and anything bigger than 4. So 5, 6, 7, 8. Plug those in. So square root of 4 minus 4, and then minus 2. So that's square root of 0 minus 2. So that's just going to be -2. 5 minus 4 minus 2 would be square root of 1 minus 2. So that's 1 minus 2, or -1. Square root of 6 minus 4 is not going to give me a nice answer. That's going to give me some decimals, so I'm just going to skip it. Same thing for 7. If I don't like the radical, if it's not a perfect square, I can just skip it. So let's try 8. 8 minus 4 would be square root of 4, which is a perfect square. That would be 2 minus 2, which is 0. So now I have 3 points. So 1, 2, 3, 4, -2. and then 5, negative, oh, I'm sorry, I graphed completely wrong. That's why I shouldn't graph late at night. 4, negative 2 is to the right. So 4, positive, and then down 2. Positive 5, down 1, and 6, 7, 8 is at 0. So notice we do still get our half of a parabola shape. Now, I would have gotten the same graph if I knew my parent, and I would have just said, okay, move each point right 4, and then down 2. Here's 1, 1, right 1, 2, 3, 4, down 2. Here's the point 4, 2, right 1, 2, 3, 4, down 1, 2. So either way, if you do it by a table or if you do it by just shifting the parent, you should come up with the correct graph. And then the final one for part 2 is number 18. So this is the end of the day 1 material. So this part right here is a piecewise function, and we need to do that by a table of values for each one. Your table is dependent on the domains for each piece. Okay? So for this first one, which is yellow, we need to pick things between negative 2 and 1, and you do include your endpoints. The reason for that is one of them could be open and the other one could be closed. The negative 2 does not have an equal to next to it, so this will be an open circle. And the positive 1 point will be closed circle. We plug these into our function. 2 times negative 2 squared would be 4 times 2, so that's 8. 2 times negative 1 squared, that's positive 1 times 2, so that's 2. 2 times 0 squared, anything times 0 is 0. And 2 times 1 squared would be 2. So we're going to plot this before we go any further. So left 2 and then up 1, 2, 3, 4, 5, 6, 7, 8, and that's supposed to be an open circle. So I'm a little bit higher than I needed to be. And then negative 1 up 2 is just a point. It's not one of the endings, so it's just a regular point. 0, 0 is just a regular point, and then the other endpoint is 1, 2, and it is supposed to be emphasized as closed. So notice we get this parabola shape for that first piece. My second table, which is my blue one, is supposed to go from 1 to 3, and we do include those endpoints. Neither one of them have an equal to, so they're both going to be open. So 1 minus 3 is negative 2, because we're using this function. 2 minus 3 is negative 1, and 3 minus 3 is 0. So plot our points. 1 down 2, and it's open. 2 down 1 is a regular point, and 3, 0 is open. So we get this part of a line. And then my final function, my green one, is for 3 and bigger. So 3, 4, 5, and it is closed because of the equal to bar here. Now there's no x up here, so what that means is the answer is always 4 no matter what your x is. So this would be 3 up 1, 2, 3, 4 with a closed circle, and this goes on forever because they do say this is greater than or equal to 3, so that would continue until we run out of numbers, where everything else had a starting and an ending point. So that is a piecewise function, and that is the end of this portion of the video.